So we're starting to review for your final exam, which is on Monday. I'm going over information or topics that you guys wanted to look at first. And so you guys wanted to review conic sections. And so looking at the following equation, you should be able to identify which conic section this is. And then you should be able to put it in the form where you could tell what the center is, if it has a center, vertices, etc. Foci. Looking at this, if I see both an x squared and a y squared, I know it's not a parabola. And if they're not the same number in front of the x squared and a y squared, it's not a circle. They're not the same number, but they're both positive. So since they're the same sign, I know that this is an ellipse. So we want to get it in the form for ellipse. An ellipse, we have x minus h quantity squared over a squared plus y minus k quantity squared over b squared. This is equal to 1. If it was this case, the ellipse was elongated, so the major axis was parallel to the x-axis, or almost identical, it could be x minus h quantity squared over b squared plus y minus k quantity squared over a squared equals 1. And then the major axis of the ellipse would be parallel to the y-axis. For an ellipse, A is always bigger than B. So looking at this, let's regroup our x terms together, our y terms together, and get the constant on the other side. And so we have 4x squared plus 8x plus y squared minus 4y equals 0. Oops. And I'm going to subtract 4 on both sides. This actually is equal to -4. I need to complete the square on both the x terms and the y terms. So we can't complete the square on the x terms quite yet because of the 4 in front of the x squared. So some of you, when you were factoring out the coefficient on the exam, you were factoring out the variable 2, and you don't want to do that. You just want to factor out the 4. And so it's 4 times x squared plus 2x. And we're going to sum something in here that will make this a perfect square. So I'm just going to leave the room. This is plus y squared minus 4y. We're going to add something right here to make this a perfect square. And so because that coefficient in front of the y squared is 1, we're just going to divide 2 into the b value of the y, which is -2, and square it. So that would be 4. This is equal to -4 plus, well, whatever we add here, we have to multiply it by a 4. So 4 times whatever we decide to add. And then plus, we added this 4 here. We have to add it on the other side. So let's determine what we need to add inside the parentheses. So take the b value, divide by 2, we get 1, and square that number, we get back 1. So this is now a perfect square. So we have 4 out front times x plus 1 quantity squared plus y squared minus 4y plus 4 is also a perfect square. This is y minus 2 quantity squared equals, well, -4 plus 4, that cancels, but we have one more 4 in there, so 4. Standard form, this is set equal to 1, so we want to divide everything through by 4. So we have this x plus 1 quantity squared all over 1 plus y minus 2 quantity squared all over 4 is equal to 1. Our bigger number is underneath the y value, so I know that my parabola shape is, or not my parabola, my ellipse shape is going to look like this. Our center, opposite signs, so h is -1 and our k value is 2. A squared is always the bigger number in the denominator when it's in standard form, so a squared is 4. I know then a is 2. So we are going to be going up and down 2 from the center. And so we're going up and down 2 from the center. is going to give us the vertices on the major axis. And so X is going to stay the same. We have -1, and we have 2 plus 2, which gives us 4. And we have -1 and subtract 2 from our Y value of 2, we get 0. Our B squared is 1. So B is equal to 1. And so our vertices on the minor axis, we're going to be going to the left and the right 1 unit. And so that's affecting the X value of your center. And so adding and subtracting 1 from the center. So -1 minus 1, that gives us -2. Y stays the same of 2. And then -1 plus 1 is 0. Y stays the same as 2. So we have our vertices. So from there, we could graph this and know what the graph looks like, but they also wanted us to find the foci. And the focus, we need to figure out what C is. And C, recall, C squared is equal to A squared minus B squared. C squared is equal to A squared is 4 minus B squared, which is 1. So I know C squared is equal to 3. And C is equal to square root of 3. The foci is always on the major axis. And so we are going to add and subtract root 3 from our Y value of the center. So X is going to stay the same. -1, and adding and subtracting root 3 from 2. I'm just going to write it because it's an irrational number. I'm going to keep it in this form. So -1, comma 2 plus or minus root 3. You should, again, be able to graph this. This problem didn't ask us to, but you should be able to graph that. Other things that you should be able to do with this is you should be able to find your intercepts, your X-intercept and your Y-intercept. And that would be showing me that you know how to find intercepts, but also within this type of problem that we're going to have, you can use your square root formula to solve. So maybe let's just do that really quickly. So let's first graph it. By graphing it, we can actually see if it's going to looks like it's going to cross or not. And so if I graph my center, we said it was at -1, 2. Our vertices, -1, 4. -1, 0. -2, 2. And sorry, where is it? 0, 2. There it is. Actually, so if I'm graphing it, right, or just looking at it, we know what the X and the Y intercepts are. So we have an X-intercept at -1, 0, and we have a Y-intercept at 0, 2. But you should be able to show that algebraically also. So given information about your conic section, you should be able to find the equation. And so in this next example, we're given that it's a hyperbola. We have vertices at -3, 3, 5, 3, and a focus at 7, 3. So first thing that you want to do is you want to plot this. So plot our points. So when X is -3, we have a Y value of 3. And when X is 5, we also have a Y value of 3. We're given that a focus is at 7, 3. So remember the hyperbola, the shape faces the foci. So from knowing where the focus is and where our vertices is, I know which way my hyperbola is facing. Okay, so our transverse axis is parallel to the x-axis. And so this is going to mean that the x value of the hyperbola is positive. So we have x minus h quantity squared all over a squared minus y minus k quantity squared all over b squared equals 1. We need to figure out what the center is. And we know that the center is the midpoint between those two vertices. Okay, so we can sum the x values and divide by 2. So -3 plus 5, that's 2 divided by 2, comma, and then 3 plus 3, so that's 6 divided by 2. Or reducing it, it's at 1, 3. So we actually know what our h value is. H equals 1 and k equals 3. So let's just plug that in there now. We know that h is 1 and k is 3. We need to figure out what A is, and we need to figure out what B is. We have enough information right now to figure out what A is. A was the distance from the center to the vertice. We're subtracting that A value from the center to get to the other vertice. So we know that this is the, we either use the distance formula, or we could probably just tell what it is, right? So if I'm going from x equals 1 to x equals 5, that distance in here is just 4. And so I know A is equal to 4. But for our piece, we want to know what A squared is. So squaring both sides, I get A squared equals 16. No, that 16 goes underneath here. We don't have enough information right now to find B, but for a hyperbola, c squared is equal to a squared plus b squared. It's different than what it was for an ellipse. We know what C is. We can figure out what C is because C is that distance between the center and the foci. And we're given one of the foci. So if we can find out what that distance is from 1 to 7, which is 6, I know that C is equal to 6. So we know C squared then is 36. And now let's use this formula so we can figure out what B is. So we have 36 is equal to 16 plus B squared. If we subtract 16 on both sides, we get B squared is equal to 20. So we figured out what the equation of the hyperbola is with those two vertices and the foci. So looking at this, I can tell it's never going to cross the y-axis, right? Both of those hyperbolas are facing away from the y-axis. It is going to cross the x-axis in 2 spots. And so let's just look at finding those intercepts. So let's find the x-intercept. So we know that that's when our value of y is 0. So we really technically have x minus 1 quantity squared all over 16 minus, well, 0 for y minus 3 quantity squared all over 20 is equal to 1. I have x minus 1 quantity squared over 16 minus, this is 9 over 20 equals 1. Let's isolate that perfect square. I could expand that out. It just would be much messier and harder to find that x-intercepts. So a lot of times there's multiple ways to go about solving these things, but there's some usually easier ways to go about it. So we always want to try to make our life easier possible. So let's add 9 over 20 to both sides. I'm going to need a common denominator. So we're going to treat this one as 20 over 20. So far we have x minus 1 quantity squared over 16. This is equal to 20 over 20 plus 9 over 20 is 29 over 20. Let's clear the fraction. We'll clear the 16 in the denominator because we want to isolate that perfect square. And we can do that by multiplying both sides by 16. So we have x minus 1 quantity squared is equal to, before I do this, let's cancel a little bit. Notice 16 and 20 both have a 4 in common. 4 goes into 20 4 times. I'm sorry, 4 goes into 16 4 times. 4 goes into 25 times. So we have, actually, I'm going to leave this as 4 times 29 over here, because I know I'm going to have to take the square root of both sides, all over 5. So we can get rid of that square by taking the square root of both sides. Don't forget the plus or minus on the one side. So I have x minus 1 is equal to plus or minus. Well, square root of 4 I can pull out. That's just 2 square roots of 29 over 5. Get x by itself, we can add 1 to both sides. So x is equal to 1 plus or minus 2 square roots of 29 fifths. So that's the exact form. I could clean it up a little bit if I wanted to. I could put it in decimal form if I wanted to. I could rationalize the denominator if I wanted to. But I'm not going to. So this next example, we're given that we have a parabola. We're given the directrix of that parabola is y equals 8, and we're given the focus is 3, 6. So again, to me, it helps me if I plot things so I know which way things are facing. And so we have y equals 8. So we have a horizontal line. And that is our directrix. Our focus is at 3, 6. So just knowing that, I know that my parabola is facing downwards. It's always towards the focus, away from the directrix. So we want to figure out, we need to know what the vertex is. And let's maybe first put in the standard form here. So because it's going this way, we have something like this. X minus h quantity squared is equal to negative 4a, because it's going downwards, times y minus k. We can figure out what our vertex is, which is at hk. It's the midway point between the directrix and this focus. And so the midway point is going to be this point 3, 7. So far we have x minus 3 quantity squared is equal to -4 times a, y minus 7. We need to figure out what this a value is. So a value, that's that distance between the vertice or vertex and that focus. And that distance there is 1. So I know that a is equal to 1. Same distance as from the vertice up to this directrix would be 1 also. And so now we have the equation of our parabola. It's x minus 3 quantity squared equals -4 times 1. So -4 all times y minus 7. Okay, so we're going to take some time now looking over sequences and series. So that was the last part of the information we learned in this class. So you should be able to work with sequences and series, and you should be able to work with those special sequences that are arithmetic or geometric. So for here, it wants us to just go in and find the first 5 terms. Our value of n goes from 1, 2, 3, 4. They're natural numbers. And so if I look at b sub 1, I'm just going in here, and wherever I see an n in this equation, I'm going to plug in 1. So I have -1 raised to the first power plus 1, all times 2 times 1 plus 3. So simplifying this down, we get -1 squared. Well, that's +1. And then we have 2 plus 3, which is 5. So we know our first term is 5. We can find the second term by going in and plugging in now 2 in wherever we see an n in our formula. So we have -1 raised to the 2 plus 1 power. So that's -1 cubed, which remains negative. We have inside that parentheses 2 times 2 and then plus 3. So 4 plus 3, which gives us 7. So b sub 2 is 7. Go in and plug now 3 in wherever you see an n. So we have -1 raised to the 3 plus 1 power, all times 2 times 3 plus 3. So we have -1 raised to the 4th power. That makes it +1 times 2 times 3, which is 6. 6 plus 3 is 9. So we have 1 times 9, get back 9. So same idea. Go in and plug in 4 wherever we see an n. So we have -1 raised to the 4 plus 1 power, all times 2 times 4 plus 3. -1 raised to the 5th power is negative. And then inside this parentheses, we have 2 times 4 plus 3. So 8 plus 3, which is 11. So you might be able to see some sort of a pattern happening here, right? If I ignore the negative signs, 5, 7, 9, 11, it's like I'm adding 2 to both sides. So I can guess right here that this is going to be +13. And we can show that by going in and plugging in 5 wherever we see an n. Okay, so a sub 1 is 4, a sub n is -1/4 times a sub n minus 1. So we're dependent on the term right before. So a sub 2 this is going to equal negative 1/4 times a sub 2 minus 1. So this is the same thing as negative 1/4 times a sub 1. The a sub 1 is 4, so we have negative 1/4 times 4, which is equal to negative 1. A sub 3, we're going to have negative 1/4 times a sub 3 minus 1, which is a sub 2. So we're going to have negative 1/4 times negative 1, which is 1/4. The fourth term, we have a negative 1/4 times the third term. So that's negative 1/4 times 1/4, which gives us back negative 1/16. And the last term, looking at negative 1/4 a sub 4. So negative 1/4 times negative 1/16, which gives us positive 1/64. Okay, so we just found the first 5 terms of a recursive sequence. So we're now trying to figure out what the sum of the sequence 3 minus k squared is from the first term all the way through the 90th term. So there's properties of summations where we can break this down. This is the same thing as the summation from k equals 1 to 90 of the first term in that sequence, which is, or in that formula of the sequence, which is 3, minus the summation from k equals 1 to 90 of k squared. So for this first summation, if we're just adding a constant, which we are, we're just adding 3, but we're adding 90 terms of 3. And so this is the same thing as 90 times R3 minus, so now we're looking at the summation of k squared from 1 to 90. So we're going to use this formula in here. So we need to know what n is for our summation. That's the highest number or term that we're going to. We're going to the 90th term. So our n value is 90. So we're going to plug it into this formula. We have 90 all times 90 plus 1, all times 2 times 90 plus 1, all over 6. So 90 times 3 is 270 minus, so here we have 90, let's maybe simplify a little bit before I move that over there. 90 times 91, all times 2 times 90 is 180, 180 plus 1 is 181, all over 6. Okay, 6 goes into 90 evenly. 6 goes into itself once, 6 goes into 90, well, 6 goes into 9 one time with a remainder of 3. 6 goes into 35 times, so we're left with a 15 there. So minus 15 times 91 times 181. Order of operations, multiplication comes before any addition or subtraction. So let's figure out what 15 times 91 times 181. That gives us 247,065. We're subtracting that from 270. So our answer is going to be negative If we summed those 90 terms, we would have negative 246,795. So for this next problem, we're given the terms of the sequence, the sum and difference of the terms of a sequence, and it wants us to express this in summation notation. Okay, so I noticed that our signs are alternating, positive, negative, positive, negative. And so to get it in that form, we know we need -1 raised to the n power. Actually, we're going to put k here, because that's the variable they use for summation. But we want the first term to be positive. And so I can't just have -1 to the k power, because that would be negative. So I could just add 1 to that exponent, and that would make that first term positive. Notice that we always have 1 in that numerator. So we need to figure out what's happening to our denominator. Well, it's just increasing by 1 each time, right? So we can just put k in here, because when k is 1, we would have 1 over 1, and that would be positive 1. When k was 2, we'd have 1 over 2, and that would be, this would give us a negative in front. So that works. We need to figure out which number we're ending in, and the last denominator is 13. So this looks like I'm summing up to 13. And so there's the summation that represents the sum or difference of those terms above. So we looked at some special sequences. We looked at arithmetic sequence, and recall an arithmetic sequence, if we take a term minus a term right before it, in a sub n minus 1, this was always equal to some common difference, which we call d. So there's one formula for our arithmetic equation. The other one is, well, if we add a sub n minus 1 to both sides, we can say, well, we can get a term in the sequence by just adding d to the term right before it. And then we did some work to figure out what the other terms were. Another way to write this in just terms of a sub 1 and d, a sub n is equal to a sub 1 plus n minus 1 times d. And we derived that formula in class. And if you don't remember that formula, if you remember the first two, you can definitely get it. Because we know a sub 2, right, is equal to a sub 1 plus d. A sub 3, this is equal to a sub 2 plus d. But we know a sub 2 is a sub 1, so we replace that a sub 2 with a sub 1 plus d. So this is a sub 1 plus 2d. And we can continue on that pattern and see that this would be a sub n is equal to the first term plus n minus 1 times d. Geometric. So geometric sequences are special in the fact that if you took a term, a sub n, and you divided it by the term right before it, a sub n minus 1, we always get the same common ratio, which we call r. So that's the first term, that's the definition. The second formula for geometric that can be helpful sometimes is our term a sub n. All that's equal to is the term right before a sub n minus 1 times whatever that common ratio is, r. And same way that we derived the third formula for the arithmetic sequence, we can also do that for the geometric sequence. So for instance, I know that the second term is equal to the first term times r. I know the third term is equal to the second term times r. But we know what a sub 2 is, and we can just go back and replace it. So this is a sub 1 r times r, which is a sub 1 times r squared. A sub 4 would be a sub 3 times r, but a sub 3 is a sub 1 times r squared. So we'd have a sub 1 times r squared times r is r cubed. And so it ends up that the nth term of the sequence is equal to the first term of the sequence times r raised to the n minus 1 power. Okay, so remembering those special equations or formulas for arithmetic and geometric, we should be able to do problems that relate to those types of sequences. Okay, so looking at a sub n, we have 4n plus 3. We want to know, is this arithmetic, geometric, or neither? And so let's show, we want to, if it's arithmetic, then we know that a sub n minus a sub n minus 1 would have to equal a constant. You're given what a sub n is. So let's replace a sub n with this 4n plus 3 minus, let's just do a little work over here for a second. This a sub n minus 1. This tells us to go in to our formula and plug in n minus 1 wherever you see an n. So we have 4 all times n minus 1 plus 3. So distributing the 4, we have 4n minus 4 plus 3. So we have 4n minus 1. Okay, so we want to subtract off this a sub n minus 1 term. So we need parentheses around that whole thing. 4n minus 1. Is this equal to a constant? So let's distribute that negative sign. So bringing down 4n plus 3, distributing the negative, we get negative or minus 4n plus 1. Notice 4n minus 4n cancels, and we're left with 3 plus 1, which is 4, is equal to d. So since we got a constant back, we can tell that a sub n is arithmetic. It's not going to be both arithmetic and geometric. So if you find one holds true, then the other one is not going to hold true. If both of them don't hold true where we get a constant, then it's neither. So if you had c sub n, let's say is equal to 2n cubed. So same sort of problem. We're just testing to see if it's arithmetic, geometric, or neither. Well, arithmetic, again, we would look at what is c sub n minus c sub n minus 1. So that would be 2n cubed minus 2. And now we're going to plug in n minus 1 wherever we see an n. So n minus 1 quantity cubed. We need to figure out what n minus 1 times n minus 1 times n minus 1 is. So let me just do the work on the side. Okay, so distributing for these first two parentheses, we get n squared minus 2n plus 1, all times this n minus 1. Distributing, I give myself more room. N times n squared is n cubed. n squared times -1, so minus n squared. Now distribute our -2n to both terms in the second parentheses. We get -2n squared plus 2n. And now distribute 1 to each term. So plus n minus 1. Let me just clean it up a little more. So combining like terms, we have no other term has an n cubed, so bring it down. We have a minus n squared minus a 2n squared. That's a minus 3n squared. You have a 2n plus 1n, that's plus 3n minus 1. So when we distribute that -2 to each term in the parentheses, bringing down the 2n cubed, we have minus 2n cubed plus 6n squared minus 6n plus 2. Notice the 2n cubes cancel, but we're left with 6n squared minus 6n plus 2. This is still in terms of n. N is still here. So this is not arithmetic. If I just got a constant, then it would be arithmetic. Okay, so let's see if it's geometric. So geometric says, if I take the term c sub n and I divide it by the term right before it, c sub n minus 1, is this equal to a constant, some constant r? Okay, so c sub n is 2n cubed all over c sub n minus 1. We already did all that work for c sub n minus 1, didn't we? So c sub n minus 1 was over here. Let's just do it right here. No, it's not my minus. It would be this. So it'd be this 2n cubed plus 6n squared. Actually, no, because I had distributed the negative. So change the signs. So minus 6n squared plus 6n minus 2. This does not, it's not going to simplify down to equal a constant. And so this is not geometric. It's neither. So looking at b sub n, we have 3 raised to the 2n power. And again, we want to test to see if this is arithmetic, geometric, or neither. I'm going to test for geometric first. And that would say that if I have b sub n divided by b sub n minus 1, I should get back some constant r. So b sub n is 3 raised to the 2n power all over 3 raised to the 2 in parentheses n minus 1 power. So this is 3 raised to the 2n power divided by 3 raised to the 2n minus 2 power. So we're going to use rules of exponent. We have the same base. We can take the exponent on top and subtract off the exponent on the bottom. So we have 3 raised to the 2n minus the whole exponent on the bottom. So put parentheses around 2n minus 2. Now, if we distribute that negative in the exponent, so we have 3 raised to 2n minus 2n plus 2 power. Notice the 2n minus 2n cancels, and so we're left with 3 squared. and this is equal to 9. This is a constant, and so this is geometric. Let's look at the following. Let me pull up the arithmetic and geometric really quick. So it's possible that you would have matrices on the final. I've done it multiple different ways before where I've just given you the system and said use matrices to solve it. I've done it where when you did your partial fraction decomposition, I asked you to use matrices to figure out what A, B, C, whatever those coefficients were in the numerator of our partial fraction decomposition. Okay, I'm going to give you these formulas on the test. I'm not going to give you all those formulas. I'm going to give you the summation formulas. So I would give you the summation formula. I don't need both of them. Let's just look at this one. And geometric, I would give you this. And you'll need to know how to apply it. So you're going to need the definition, how to find the nth term. You'll need to know those of an arithmetic and geometric sequence. Okay. So if we have, how about the summation of k equals 1 to 7 of 1/3 times k. These look really good. Find the indicated term in each sequence and find the general term first. So let's say we have, this one looks hard, so I'm just going to do it. √2 to 2 to the 3/2 dot, dot, dot. Okay, so we have 3 terms of our sequence. Let's find a sub n, and then it wants us to find the 9th term. So find the formula for a sub n and find the 9th term. Oops. I thought I was recording that. So we had just looked at this one problem in front of us where we had square root of 2, 2, 2 to the 3 halves. We were asked to find the nth term and asked to find the 9th term. We rewrote that square root as a 1/2 power and noticed that we were increasing in our exponents as for 1/2 each term, which meant that it was exponents like it was arithmetic. And so I used that fact that the exponent was an arithmetic sequence to figure out what that exponent had to be. And we found out that we got 1/2 to the n power. This here was just checking to make sure that what we had determined to be the formula was correct. And then we figured out what a sub n was, which was 2 raised to the n divided by 2 power. So now we're given information about a geometric sequence and we're asked to find the formula for the nth term. We're given that the second term is equal to 7, and we're given that the fourth term is equal to 1,575. So basically we have 2 equations and 2 unknowns. We're going to use the fact that geometric sequences can be written as a sub n is equal to the first term times r raised to the n minus 1 power. Okay, so our n value for a sub 2 is 2. And so let's set up the equation. We know a sub n when n is 2 is 7 is equal to the first term, a sub 1, times r raised to the, and here we're plugging in 2 minus 1 power. So this would be to the first power. So there's one equation. Now let's look at the equation for a sub 4 equals 1,575. So we know we have 1,575 is equal to the first term, a sub 1, r raised to the n minus 1 power. So n in our case for a sub 4 is 4. So 4 minus 1 power is a 3. There's a couple ways that we can approach this. I think the easiest way to approach this is let's divide one equation by the other equation. And if we do that, then our a sub 1 would cancel out. So notice if we took that second equation we had found for the third term or fourth term and divided it by this second term, we have 7 going into 1,575. Let's see if it goes in evenly. That's 225 is equal to, notice our a sub 1's cancel. And if I have r cubed divided by r, using rules of exponent, this is r squared. So we can find r by taking the square root of both sides. And so the square root of 225, yeah, it's 15. So we know that r is 15 in here. If r is 15, now we want to figure out what is a sub 1. And so go back to one of your equations and let's plug in what r is and figure out what a sub 1 is. So if we plug r in here, we have 7 is equal to our first term times r, which we were given or we found was 15. Let's divide both sides by 15 to get what a sub 1 is. So a sub 1 is equal to 7 over 15. So our nth term is equal to our first term, 7 over 15, all times r, which is 15, raised to the n minus 1 power. Okay, so we have one more problem in front of us. This time we're given the terms of a sequence and we're summing those terms of the sequence. We're given the sequence is geometric and we want to know, does this converge or diverge? So we really need to know is what is our r value? So recall for geometric, we can look at any term divided by a term by right before it. So if I looked at my second term divided by my first term, that should give me the same R value by any two terms sequence that are right next to each other if we do that. Sorry. So a sub 2 is 1, a sub 3. Sorry, a sub 2 is 1, a sub 1 is 3, which gives us R. Right, I'm just going to show you really quickly that we would get the same thing if we had chosen a sub 4 divided by a sub 3, right? 1/9 divided by 1/3. Well, that's 1/9 times the reciprocal, 3/1, which is 1/3. So you can see that R is 1/3. The summation is going to converge, meaning it's going to go to a finite number if we sum those infinite number of terms. And I'll give you this formula. So we need to know what the first term is. Well, you're given the sequence, so you know what the first term is. The first term is 3. So the summation to infinity is equal to the first term 3 divided by 1 minus R, which is 1/3. Let's just clear our fractions by multiplying by a fancy one. That fancy one is going to be 3/3. And so that gives us 3 times 3 is 9, divided by distributing that 3, we get 3 minus 1. So if we summed an infinite number of terms for that geometric series, we would get 9/2. So I'm just going over really quickly how to figure out what grade you need to get on the final exam to get a particular grade in the class. You have 2 scores that you're going to be given, your class average, your score in the course with all of your grades in there. And if you were using that grade, that's worth 75%. X is equal to the grade you need on the final. The final's worth 25%. If you're trying to get an A, do 90, B 80, C 70, D 60. Let's say that you're a student and you're coming in with, let's say, a 79%. Let's say your CA was 79%. And you want to know, can I get an A in the class? So to see if you can get an A in the class, we would go in here. We're going to plug in your class average, which is 79. I'm not going to put it as percent. If you wanted to put it as 0.79, that percent, then you would have to put this side of the equation as a percent. So plus 0.25x is equal to, let's see if this student could get an A in the class. So let's look at what 79 times 0.75 is, and that is 59.25 plus 0.25x equals 90. So we want to isolate our term with x. So we're going to subtract 59.25 on both sides. So we get 0.25x is equal to 30.75. So let's divide both sides by 0.25. And we get x is equal to 123%. So the student could not get an A in the class. So that's impossible, but they probably could get a B in the class. And that was, though, looking at their score as if it was, we're not dropping a score. Let's say that the student also looked at their class average with a drop. So let's say their class average with a drop. Let's say that their score was, it's going to be higher. So let's say it was 84% or an 84. So let's see with that grade if they could get an A in the class if we used this formula. And so we have 84 times 0.6 plus 0.4x is equal to 90. 84 times 0.6 That's 50.4 plus 0.4x equals 90. So subtract 50.4 on both sides. So we have 0.4x equals 39.6 and divide by 0.4. We get x is 99. So it would be possible if this student had come in with a CA of 79 and a CA with their lowest score being replaced with a final, they could still get an A in the class if they got a 99%. So those are just some examples of how to go through to figure out that grade in the class. But these are the two formulas that you're going to need when I give you those scores of your grades in class. So I'm going to do that breakdown of the grading again so that you could see if you can go in and up your score on my math lab for your homework. You can always do that. Also, you guys have one more end of the chapter test left, which was on that chapter 13, the arithmetic sequence in series. And so that will open up on Friday, and you'll have 3 days to do that.